While browsing on eBay, I came across this little delight. It was fairly cheap, and I thought that'd be quite fun to take to bits. And I particularly like the fact that it's a flying, self-contained disco ball, but there's absolutely no control over where it flies. It just basically does its own thing. So let's demonstrate this. You turn it on by clicking a button underneath, and there's a small pause before the blades start. And then, see, that's not very helpful. Come here. Right, okay, let's try that again, right. Stay. Yeah, this thing anyway has infrared sensors underneath it. It's just going to attack anything. I mean, seriously, there is no control. It just basically goes where it wants to go. And I suppose that's down to air turbulence in the room. And it's got the infrared sensor underneath that when it detects an object underneath, it basically just increases the speed of the blades. And most of the time it kind of semi-behaves itself, but very occasionally it hits something and then it goes off at a random tangent, and it seems to run for quite a time in the batteries. And you can grab it, but if you try and grab it from underneath, it immediately runs away from you. Let's try and bring it back. So if you go underneath and try and grab it, it will instantly just launch. Oh, now it's hit the ceiling and it's not coming down. Come here. But if you actually, I'll wait for it to make appearance, grab it from the side, you can just grab it to reposition it. It's a lot of fun. I've spent a lot of time playing with this thing. Ugh. And it's particularly fun when it goes off out of control because it just goes off at a random tangent quite explosively. And when it hits something, it stalls and then it starts flashing. You can see the disco ball effect here now, it's doing that. So let's take it to bits. So let's take a closer look at this sweet little ball of destruction. And aside from the high torque motor and the little lithium cell inside, the real science to this is the blade assembly, because it's got counter-rotating blades. When one rotates the other one way, the other rotates the other. And they have these little balance weights that change the pitch of the blades. Very, very clever. The only point I managed to break this, I managed to pop one of these out when it slammed into a wall, but it was quite easy to put back together again. On the bottom of it, it has an infrared emitter in a guide tube to stop, mainly to direct the light down a sort of beam, and an infrared receiver. The charge socket is in the middle, which this USB charge lead is used to charge it, and there's the button which turns it on and off and resets it when it crashes. If it does crash, it just stops the motor and it starts pulsing the lights. It must be a current sensor. So what am I expecting to find in the circuit board in here? I'm expecting to find a small motor that probably I can see from the outside here. I can see the lithium cells on the other side from the motor. Well, let's just open it up. I'm expecting to see the circuit board. Long, thin screwdriver for this. And really not an awful lot much else, because it's a very simple arrangement. It's maybe going to have a chip on board, a little blob, or it could be a little ubiquitous 8-pin chip. So what have we got? Oh, there's a little ubiquitous 8-pin chip. Right, so what have we got in here? The whole lot comes out, so you can have a flying chassis now with circuit board dangling. That's quite tempting to have that flying right now. Oh yeah, that's quite appealing, just having a flying chassis. Rightio. So there's the motor, which is glued in. I thought that was grease, but it's glue. The lithium cell, which, you know, for the size of the lithium cell, it's a fairly fat-ish lithium cell. It's got a pad there, so it's obviously capable of taking a bigger one, although that might affect the balance somewhat. But it lasts a long time. And it's capable of putting out a modest current too. We've got the circuit board with, I thought there were just 3 LEDs in it, but there's actually 3 on each side of the LEDs. 1, 2, and 3. I'm just going to make sure, let's zoom in a wee bit further in fact. Let's zoom right up on this. And then focus again. Did I just defocus that? I probably did. Hold on, I'm just going to use my notepad to focus down, because that's a more accurate focus target. There we go. So what do we have? We've got the 3 LEDs. We've got that little 8-pin chip. Does the 8-pin chip have a number on it? This is where you guys can probably see it's not got a number on it. Well, that answers that question. Is it switching the current to the motor as well? I think it may be doing just about everything. There is a small transistor down here and another one up here. Tell you what, give me a moment and I'm going to try and reverse engineer this as much as possible, but it's not going to be too detailed because there's just not an awful lot to it. One moment, please. I've taken a picture of the circuit board and blown it up in size so we can look at it together. The back of the circuit board has virtually nothing on it. It's basically just got the links and the three LEDs that match these ones here. So these big white things are basically the red, green and blue disco LEDs, which are replicated on the other side. There is one other LED and it's down here. This LED is the charge indicator LED. It glows red while it's charging, and that's controlled by this chip here. So when you plug the jack in here, the charge jack from the USB power supply, this chip here has the current set with a resistor, and it also limits the current to the charging of the cell with this heavy red and black wire, and it also shuts off when the voltage has reached the maximum voltage, and then at that point the red LED goes out. The whole chip appears to be controlled by this 8-pin, the whole thing appears to be controlled by this 8-pin chip, and I thought it was a dedicated chip that did power switching as well, but it's not. It appears to be a standard microcontroller, and it follows the standard topology of pin 1 being positive and pin 8 being negative, with the others just being general inputs and outputs. That transistor there is driven by a 1K resistor from one pin of the chip, and that switches on all the other LEDs via their own resistors. This transistor down here, that one up there is a J3Y, this one is marked A2, and this actually switches the motor. And it's interesting to note that it's directly driven from the output of the microcontroller via pin 6. But pin 7 is also used to monitor the output of that transistor, so that when the motor stalls and the voltage across the transistor flies up too high because of its internal resistance, it signals back to the microcontroller. It might be using analog to digital detector to actually monitor that. So it can detect that stall condition just by that one resistor from the transistor. The motor itself is these red and blue cables, and under normal operating conditions it seems to draw only about 1 amp, which is quite surprising. I thought it was going to be a lot more than that. The emitter here may actually just be powered from this same transistor, and it emits a beam of infrared down the way. That's detected by this detector, which then goes back to the microcontroller and has a very high value pull down resistor of 1 megohm, presumably just to avoid discharging the battery when the unit's not in use, since that would still remain active, that circuitry. And that detects when something comes close. This will detect the modulated infrared. That does suggest that infrared's modulated. That means that I may be wrong there. Hold on. That pin goes over to... Yeah, I think that may actually be being modulated by the chip. Okay. Right, but this unit detects that infrared and it increases the microcontroller, then increases the speed, presumably by pulse width modulation. It's the only really way I can think it would do that. There's a switch here for turning it on and off. That is simply going straight to the microcontroller. I might be using internal pull-up, since I'm guessing this is probably pulling it down when you push the switch to the negative rail. That's fundamentally it. So there's a charge section, there's a microcontroller switching the LEDs with this transistor, the motor with this transistor, it's got the button, it's got the 2 detectors signaling back to the microcontroller, the charge port. That is fundamentally it. Very, very simple. Now, earlier I mentioned that having taken it apart, it'd be quite entertaining to run it without the globe on the bottom. I tried that. The globe acts as a bit of weight. It's obviously counterbalanced. It's obviously programmed in software to sort of an average value for the boost level and the sync level when it's not detecting the infrared. And without those, it just flies up, it hits the ceiling and scatters about in the ceiling for a while before crashing randomly in a random direction. I reckon if I put it outdoors, it would fly up just continually into the sky. I'm not sure what height it would reach. It goes for some length of time in that little lithium cell. And with its bright LEDs shining, you'd probably cause a UFO scare, and that's almost worth buying one for. So, in the description down below, I'm going to provide a search link for eBay so you can find these. And that will avoid that situation. If I put a link to this exact one, the price in that listing will shoot up. So I'll just provide a generic search link. But it's cute. It's very neat. I have spent a lot of time playing with this. It's been charged and recharged a lot because it's just a fun little thing. And now I'm going to reassemble it and play with it again.